Welcome to a new Learn Software Architecture episode where we are going to focus on the next step of evolutionary architecture. This time we will focus on growth. If you remember, we started our application with a really simple code. One solution, one project with production code and some projects with testing code, and that was it. Next, we moved to something that was easy to maintain, and this was the application that was divided into separate projects. And till some point it would be enough, especially when our assumptions regarding MVP version are that we are going to serve 5,000 users, we will have a single development team, the frequency of changes will be quite regular between modules and so on. At some point, your application might hit a wall, and that might be related to the number of users that grow. And imagine that instead of 5,000 from initial assumptions, you would have 500,000 after a year or so. Additionally, one of the modules, like contracts, will start to change way more frequent than other modules. You can expect the ratio of 10 to 1. So one change in other module means 10 changes in contracts module. Another point that you might face is that team that used to work on it is not enough. You will have 2, 3, 5, maybe even 10 teams at some point that will work on the same code base. And that's why you should start thinking about how to tackle these problems. Based on the current state that I mentioned, we have 4 decision factors that can tell us that, hey, take it and extract it to a separate deployment unit. So let's look at these 4 factors. First of all, this is enormous usage. You are scaling modular monolith to a point where it is too expensive because you will need maybe 100 instances of entire application. Second, frequency of changes, because you are changing it way more often than other modules. I mean here this module of contracts. Third of all, there might be a security level that is required to be higher for a contracts module than for other modules in your application. And fourth, this number of teams that will work on your code base. You might think that it's just extraction of one module to a microservice, but that's not true. If you watched previous episodes, probably you remember that besides business modules like passes, offers, reports, contracts, there was as well some module for building blocks that was called common. And in this common module, we have some reusable mechanisms for all the modules around. For example, it can be exception middleware or something like this. Now you need to take this common module and extract it to some kind of a package that can be referenced by both processes. One which is related to microservice and one which is related to modular monolith. So to do that in elegant way, you can extract it to a separate package and reference it through a nugget inside modular monolith and in a microservice. However, now you need to remember that there is something like versioning. So if you change something that has breaking changes in your package, you need to update major version. Then if you change anything else, it will be minor one, and if you fix a bug, it will be a patch. And if you upgrade it, you need as well to remember that it would be nice to keep the newest version in modular monolith and microservice. So on a regular basis, it should be updated to the newest version. And how to communicate between modular monolith and microservices. In previous chapters, it was easy. You could just use in-memory queue, additionally maybe some outbox pattern, and that was it. You could consider a separate component for communication in chapter 2 where we were focusing on maintainability, but that was optional. Now it can't be optional. You need a physical component that will allow you to communicate between your modules in modular monolith and a microservice. Additionally, there is now a need to have some kind of API gateway where we will be able to forward our requests that are related to contracts, microservice, and if this will be related to modular monolith, then we need to forward it to modular monolith. So now you can see how much did we complicate things. Before, we just had modular monolith and some load balancer in front that was responsible for forwarding requests to first, second, third, fourth, fifth instance of this modular monolith. Now we have API gateway, we have modular monolith, microservice, component for communication. So we have 4 things instead of just 2. Now you can see that bringing microservice to the table can bring you a lot of changes and a lot of problems that you haven't had before. Let's have a look at the picture that represents the current state of our system. First of all, we have API gateway, and it handles all the requests that are coming from our users. Next, this API gateway forwards the request to a microservice or a monolith, depending on the business logic that we need to handle. If this is related to contracts, then it goes to the contracts microservice, otherwise it goes to modular monolith. Both blocks have to somehow communicate between each other, and this is handled by our communication component. It can be a combination of RabbitMQ and mass transit or any other message broker that you can think of. Next, we have building blocks, and these building blocks are a separate block, as mentioned before, which will be closed into the package and then referenced by a microservice or monolith using NUGET or any other mechanism. If you remember, our monolith was referencing the database, and this database was split into schemas. So we had schema per module. Now when we have our microservice, it makes sense to just grab this schema and extract it to a separate database, because when this database for modular monolith fails the instance and you won't have an access to it, different things can happen. Then this microservice can still operate on its own instance, its own database that is just related to contracts. And the last thing which we have here is to remember that whenever you have problems with performance with this database and microservice, you need to just repeat the same steps that you had with monolith, depending on the need. If it was writing problem, then you have to think about sharding. If it was a read problem, you need to think about read replicas or use cache in case these read replicas are not enough. And this is something that I would like you to remember, that whenever you introduce this microservice, just one extracted from modular monolith, tons of new problems will appear. You will need to think about things that were not happening before. That's why you should make wise decision if you would like to go within microservice or you want to stay in modular monolith. As you can as well see, it's possible to combine modular monolith and microservice. Still, there are problems which are related to distributed systems, and you need to be very careful while doing that. Let me know what you think about this third step of evolution. In case you are interested in how it looks like in practice, you can check our evolutionary architecture repository that is written in .NET, and there you will see all the assumptions, these decision factors, and the way how we implemented it in .NET code. On 29th of April, there will be a new series on Learn Software Architecture led by Radek Maziarka, and it will focus on book, technical book, and each episode will focus on a different book. The way how it is handled is something similar to a workshop. So feel free to join the first episode of it, and I wish you a great week. See you next Tuesday, while talking about the last step of evolutionary architecture called focusing on complexity. See you there.